Okay, and so now let's just do another example. So we have that now I want to find the derivative at 1 for this function. So I'm just going to start with the definition. So I'm going to say the derivative at 1 is equal to the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. Okay, and so now I just want to, like I did last time, just figure out what f of 1 plus h is and what f of 1 is. So I have that f of 1 plus h is equal to negative 1 plus h squared plus 1. Alright, so wherever I saw an x, I plugged in the whole quantity 1 plus h and just make sure you use parentheses. And so now at this stage you might be like, okay, what is 1 plus h squared? Well, here I'm just going to use the formula that I have highlighted in pink at the top here. Alright, so this is going to be, I'm noting to you that a plus b, the whole thing squared, is a squared plus 2ab plus b squared. And so this just comes in handy instead of trying to FOIL and all that fun stuff. So here I'm going to say that this is 1 squared plus 2 times 1 times h plus h squared, and then plus 1. And so when I simplify this, I get negative 1 plus 2h plus h squared plus 1. And when I distribute the negative, I get negative 1 minus 2h minus h squared plus 1. And so I get that this is negative 2h minus h squared. Okay, and so f of 1, you just want to plug in 1 in for x, and so you get that this is 0. Okay, so now I'm going to plug in these pieces into this limit definition here. So this gives me, this is equal to the limit as h approaches 0 of negative 2h minus h squared minus 0 all over h. And simplifying this, the numerator here, I get negative 2h minus h squared all over h. And so now we want to try and plug in and see what happens. But what you notice is you get our fun indeterminate form 0 over 0. And so now we want to go through the techniques. And first I try to see if I can factor and cancel. And so in this case, you should notice that I can in fact factor the numerator because they both have an h in common. Alright, so I'm going to factor out an h in the numerator. So I have this as h times negative 2 minus h all over h. And so now you notice that these h's cancel. And so this is equal to the limit as h approaches 0 of negative 2 minus h. And so now this is the stage where you plug in 0 for h and you get negative 2. Alright, and so here plug in 0 for h. And so you notice again that once I plugged in, after I factored and canceled and I plugged in 0 into the limit, I stopped writing the limit notation. Alright, so that's when you stop writing.